So welcome, Kurt Grandis.
Thank you. Thank you. So we're going to be talking about the future of earlyhood childhood Python education. So what does that mean? I want to talk about how do we get kids involved in Python or get them prepare them for Python. We're going to talk about some existing resources that are out there for the Python community, as well as some resources that are out there and up for other languages. Talk about a bit of what some of those other communities offer, as well as what we can do to help promote and prep our kids to be ready and promote Python as a language for education. I don't have any answers. I just want to get this discussion started. So really, I want to put some ideas out there, but I would love to hear from you, and if you guys have thoughts on things, directions that we can take it, please let's talk afterwards. Also, I'm using the term early childhood education a little loosely. Typically that's under age 8, maybe thinking around age 10. So if you have an aversion to 9-year-olds, feel free to take off now. So last year at PyCon, I gave a talk about how to militarize your backyard and fend off the squirrel hordes. Basically, this was a open computer vision project where I trained a system to identify squirrels, avoid birds, and squirt the said squirrels if they get too close to the bird feeder. It was kind of a hacker-maker project that, I had a problem and just kind of dove in to do this. And apparently, it went over really well. It was all using Python, and it went over really well. After PyCon, I started getting started making the mainstream geek news circuit, started getting calls from different media outlets and producers, and ended up making Popular Mechanics, which was really awesome. I even got a little cartoon rendering of myself, which I think was one of the big pieces of that whole talk. So I say all of that because once this thing started getting out there, I started getting tons of emails from people around the world, and I learned a couple of things. One, people really hate squirrels, deer, raccoon, bears, heron, kids, rabbits, you name it. They really wanted to share their wildlife war stories with me. And some of you have some severe anger management issues as well. Maybe not in this room. The second one was huge, though. A lot of the emails I was getting was when something along the lines, I watched this video with my child, or we watched it together, and we were both really excited, and we want to get involved. How can we do this? How can I get my child involved? Where do we go? Some people, I don't know how to program, but I still want to do this. So, I was absolutely thrilled. It's amazing that this project could spark that interest in this many people. So, but now here I am, people turning to me oh, how can I? We're putting our child's life in your hands. How can we do this? So, what resources do we have as a community, and what do I write these parents and teachers? As a community, what do we have, and what can we do? Which is kind of really what I want to talk about today. And quickly, why am I even talking about education regarding this? I just shoot squirrels, right? So I've played in the educational technology world for about eight years or so. Before that, I was a neurobiologist where I tormented other forms of rodents, and studied learning and how learning occurs and how our brain enables a lot of that. I'm active in local community doing outreach, developing enrichment programs for kids, both in class and after school programs. And then at home, that's where my real motivation is, where I have my home laboratory, where I can test things out on my 2 children, and it doesn't matter, yeah. So I get to see what works and what doesn't. And so a lot of the things I tinker with, I start from home. So this was, I think, a really exciting opportunity for me. So, let's get started there. What can we do to introduce kids and keep that motivation going through the world of programming in terms of Python. So I know a lot of you are probably going, oh, why does everyone always talk about robots and zombies? But I mean, the robotics world like ends up building so much motivation so quickly, that spark of interest within youth and adults. So there's something certainly intriguing about that. And, Edward Tufte talks about how in giving presentations or communicating with people, having a physical object in your presentation, something that can bring in multiple senses, can be a powerful focus for those that you're communicating with or talking to. And that's, in a way, that's what we have with robotics. We can elicit some sort of a primitive reaction from folks, from kids with a physical object. And that's what we're seeing in the human computers interactions research and cognitive research, that the physical embodiment of avatars can have a greater motivational impact than the virtual avatars. So having a little robot on your screen saying, "Way to go, champ," isn't quite as good as having a little robot standing next to your screen going, "Way to go, champ." There's a slight difference in that level of motivation. So let's build a robot. We'll give the kids like direct access to this robot. You can send commands to it. The robot will execute that. It'll be awesome. We'll even put in the ability they can alter their environment. This is going to be so sweet. So, not a new concept, right? 1969, out of MIT Artificial Intelligence Laboratory, brainchild of Marvin Minsky, Seymour Papert, Cynthia Solomon. These folks, like if you've played with Logo, the little green triangle that you move around, or if you're a little older, the little green turtle that you move around the screen, you ever wonder why they call it a turtle? It's because they built that little guy, that little drawing machine that would move around. Kids could write programs and interact with its environment. They'd program with it, explore. It was genius. And they even deployed it into schools where it was very successful. So, why wasn't this widespread? Why weren't kids across the US exploring and constructing and building things with this? I think, for one, the hardware cost was enormous at the time. In order to even operate this, you would call in over a modem to a PDP mainframe that was running the Logo interpreter, send those commands to the interpreter, which would then generate the hardware commands to send it back to the turtle. The turtle itself was custom machined and milled and wired by folks, so cost was certainly a limiting factor. So it's understandable that the little green triangle turtle simulator was a much more cost-effective solution to distribute this idea in mass. So today, you can buy a cheap robot chassis, whether it's like this or smaller with a tighter turning radius, for $20. You slap on an Arduino processor to control the motors, or your brand new Raspberry Pi. And you get wireless interface and a shell terminal to operate these sorts of things. And you're ready to go. I mean, you have a commodity turtle that we can go. This is one, this little guy I'm working on right now. It's not quite finished, but it's a much more reasonable investment to give kids a cheap robot to interact with and draw. And I mean, I duct taped a pen to a robot, and so it works. But if you want something a little more polished without duct tape, or as much duct tape, we can look at things like the Lego Mindstorms. And this is amazing. Imagine programmable robotic Legos. Legos currently kind of targets ages 8 to 14 with their Mindstorm, but I know a number of programs and camps, after-school programs that target even younger, 6 and up. It really depends on the kids, but it's a great platform that gets a lot of interest. So we have community programs where people go out for after-school programs or weekend projects and just work with kids on exploring and labbing up some of these Mindstorm things. By default, or by the manual, you program this with a C-like language called NXC, not exactly C. But you can use Python if you wanted to. So there's two packages that I know of. NXT Python, which is more of kind of a real-time, like translate commands from Python directly to the brick and operate those commands. And then you have PyNXC, which is more of a translator that translates Python into NXC, so it can be uploaded directly. The programs can be uploaded directly to the brick. So, this sort of tool gives you much greater control over your environment. I mean, this thing's got all sorts of sensors, some cool-looking graspers. I mean, there's a lot you can do here. And LEGO's announcing this year they'll be releasing their next generation, the EV3, which is going to be built on Linux and offer, I think, a lot more competitive offering with things like the Arduino and the Raspberry Pi. So people will be able to hack on it. And I think because of that, we'll see even better integration with Python coming up. I don't know yet. But so this comes with a price tag of about $350. So it's not exactly cheap. And you run into some kids who are also like, I don't know how to build a robot. Like first, I don't even know how to program. Now you want me to build a robot? Like, oh, I hate you. Like, it can be intimidating. So can we take a page from the Logo simulator, the turtle simulator? Can we build a simulated robot that kids could use as a stepping stone to build some comfort? So, and this isn't an unpopular concept either. I grew up loving some of these games here, like Robot Odyssey and Omega. I think these were for like the Apple IIe or maybe GS. The Omega allowed you to program a battle tank. You write code to manage reading the sensors, detecting where your enemies are, evading and moving around the terrain while you're trying to attack your enemy. And it was great to just play around and sort of build these sorts of things. I'm just curious, did anyone in this room ever play any of these games? All right. So I came across this one, RoboMind, which appears, it's kind of like a modern day incarnation of some of these games, or the turtle environment, I think. It provides a more rich environment than the Turtlescape, in that, you're a robot and you can move around this map with various obstacles and terrain. You can manipulate objects, pick them up, and you control the little robot using a C-like language called Robo. And you can give kids different missions or assignments based on the map and the objects that are on there. It's really cool. I haven't seen any RoboMind wars set up yet, but that would be kind of cool. The other nice feature of this environment is once you've programmed your little simulated robot, you can plug it right into your Mindstorm and export and control your Mindstorm robot the same way you controlled the simulated version. No Python. But keep note of that. I want to come back to this one a little bit later. Another thing to note is, there's not a ton of research here, but the idea the differences between using real robots in education and simulated robots. There's at least one study I know of that dealt with taking a class, one group of kids who got to play with real robots and then simulated. And there was no real significant difference between those groups as far as subject matter mastery. The big difference in this was the kids who played with the robots had a more positive attitude about the classroom activities. They were using a robot, so that was pretty cool. And they were also able to better predict the execution of what the programs would do before they executed them. Maybe there was less abstraction for them to have to do because they'd actually seen this thing move around. So, enough with the robots. How else can we give kids an environment to play in, to explore, construct, and play? So Scratch. I'm sure a number of you have seen this. It's a very popular graphical programming environment. that allows kids to easily create scenes, skits, and games using this graphical programming interface. And if you're not familiar with it, the idea is each of those little blocks over there represents a command or variables. And you can see in this, I think the second column, that yellow brick is more of like a control structure. And you just plop in different variables, and it runs down those list of commands and animates that little sprite or whatever you have there. It's a graphical environment to do that. And this is all powered by MIT's Media Laboratory. And it's a tremendous following. And I think one of its big successes is its community. It's really easy to share programs that you've made with other people, and you can pull down programs that other people have made and hack them and modify them. It also works on Raspberry Pis. Scratch is built in Squeak Smalltalk. No Python interface. There's some Python tools to modify Scratch files, but nothing to actually tweak those sorts of things. So one of the problems I've had with using Scratch, and I've heard other folks say the same sort of thing, is you get to kind of a dead end. You invest time in teaching kids about Scratch, and they get it. They made their sprite, they move it around, they made it say some things, and it's done its job, but now they understand these concepts, and they're ready for a more traditional sort of environment, but it's really hard to transfer this anywhere. So imagine, if you had a Python-based system like this, where you could peel back that graphical interface when they were ready, and it turns out all those blocks were actually written in Python code, and you could you could still write your code to the stage and control the sprites, but now you're writing Python. You just have a different interface to that. That would be awesome. I would love that. All right, let's come back to that one in a sec, just to be able to create that sort of transferable knowledge. So Walter Bender of Sugar Labs, he created a graphical block programming system called TurtleBlocks. This is developed in Python and has a lot of similar characteristics to Scratch. I just discovered this myself yesterday at the Educational Summit. It's amazing, all these educational efforts, initiatives that are going on, and folks aren't talking. And I think if we start communicating, there's a lot we can discover and share. I'm looking forward to digging deeper in this to see if this is a tool that we could use to reveal that kind of Pythonic translation of these blocks. Game development, a number of studies and panels have talked about using games as a first step motivator. People like games, kids like games, so if we can give them games, we can build that motivation first. So if we can give them fully operational code, or they have a place to start to modify before we start sitting them down and teaching them first principles. Here's a string, here's an array. They haven't invested yet. Why do I care about these sorts of things? And if we can establish the motivation, or what they're going to get out of it first, that can be really helpful. And actually, just last week, I think there was a story on NPR about a guy who modded Donkey Kong. His daughter was kind of upset that, why did she have to be Mario saving, I know it's not the princess, I don't know, did she have a name? A little Peach? Okay. And she wanted to be Peach. So, this is an awesome piece of of motivation and exploration together. So he modded the game so that she could be Peach and she could rescue Mario. That's great. All right, so what sort of resources do we have in our community to throw at kids, or whether you're working with them or not, that have established games ready to go along with source code that can be hacked or tweaked? So first, I'd like to point right to Katie Cunningham's Pygame-based Rogue game, and there's a blog series around this too about how it was created. They used this during the Young Coders session this past week, and it went over, I think, really well. It's simple enough and complicated enough and interesting enough, and provides enough places to tweak and mod, whether it's from changing game mechanics to creating new magic items. I think there was magic pants of breathing yesterday. I liked. The other game Making games with Python and Pygame is also an excellent resource. I think there's like 11 games in here. They all run on Raspberry Pi, a lot of material. And I think some of the games are even like Snake. And then my kid's favorite next to Minecraft Pi is like this cannibalistic squirrel eats squirrel game. But there's a lot going on there. And so once you've established that level of motivation, and the kids want to do this, right? Or maybe you're working with someone who needs foundation first. Like I need a solid grounding. We have plenty of traditional structured Hello World things that will start with first principles and work up. So once you work with Hello World, they can quickly explore the various nuances and possibilities that gives you. Some great, I think, books to get started or to work with kids in this area are the Invent Your Own Computer Game and Python for Kids. Both of these start you off in Python 3. There's also the Hello World Computer Programming for Kids and Other Beginners. The SANS were also at the Educational Summit, which is great. This is an excellent book. I've used pieces from that in some of my programs as well. Even without touching computers, you can begin to cultivate computational thinking, and that can go a long way to preparing kids for the concepts of computing. Getting your children to think critically, analyze problems, decompose scenarios or problems, identify patterns, problem solving, starting that algorithmic construction. It's really just asking questions and guiding things. Guiding discussions, playing games, board games, things with rules, talking about learning strategies. How can we automate these things? How could you teach someone else to play this game? What are the rules associated with that? There's a whole range of things that can be done outside of the computer to prepare for those sorts of activities. There's some language-independent games for the web and iPad that let you play with like algorithm design in the sense that you have the control of some avatar or agent, and you graphically command them to do different things ahead of time. And there's a lot of steps there. How young? So I haven't mentioned a lot about age and appropriateness for what's appropriate for whom. And I think the big reason behind that is it depends. Especially with computing. I mean, the kids around the world are at such different levels of readiness depending on their physical and mental abilities, as well as the level, I think more importantly, the level of exposure to computing systems and devices in their environments. I know I've watched younger and younger kids manipulate computing devices with greater ease over the past few years. Motor development is an issue with mice for the younger end of kids. Research has shown that younger kids tend to be slower and make more mistakes than their older counterparts. No big surprise there, but the more significant factor is exposure. The more they play with it, the more they get better with it. And since those studies have come out, there's like a whole other market for the little kid-sized mice that are even smaller. And developmentally, I think by 6 or 7, you see a jump in performance, and then again, a couple years later, it all depends on the individual as their brains and bodies mature. But yeah, I mean, are mice really going to be all that important? I remember like some of my daughter's first interactions when seeing like a flat screen TV was going up and touching it. Like that was her first instinct, was to have a touch screen, and that kind of just blew my mind. Like, wow, I didn't have that for a long time. Also, literacy can be a big factor, but just because the kids can't read the books themselves doesn't mean that they can't think about the computational matters. I mean, with you as a guide working through these problems, you can help move things forward. And I've used the same motivations that you're using for programming to help practice reading skills or letter recognition, things like that. If the motivation's there, you can bring this all in full cycle. So I think the idea is be an empathetic mentor, feel out what they're ready for, try not to underestimate them, be conscious of attention and frustration levels. Particularly for the younger kids, I think it's a lot more about exposure than mastery. One day it'll click. Be a good teacher, don't be a bad teacher. Ideas. So what can we do as a Python community? I think this year with the educational summit that came out, it seems like there's a lot of interest from folks who maybe aren't even from a traditional educational background, but see the value of it and want to do something. They want to get involved, but maybe don't know how to do it. What resources do we have, and what can we do? What can we build? So I'll just share a couple ideas that I have, and I love to hear any ideas that you all have. So one we talked a little bit about is a Python-based Scratch-like environment. I want something like TurtleBlocks or Scratch where it's really just translating or hiding the Python code behind the thing. I can peel it away when they're ready, and then we can work in Python. The Scratch group is also, there's some research going on for Scratch Junior. That interface can be simplified for the younger kids, the pre-literate or emerging readers, where you have even more symbolic interface. You could do the same sort of thing. Just so you have the code level, the graphical interface level, and then maybe a simplified graphical interface level. The other big one is a Python-based RoboMind like simulator. What can we do here to create a more exciting turtle environment where kids can interact and use Python? So that's what I have here. I'd love to hear ideas that you guys have.
Okay, we do have time for a few questions.
But I know there was a big market for educational software. I did Jumpstart for Kids, 4th grade, Jumpstart for Kids, 5th grade. And that's like a very mainstream thing. It would be really, and then you just get the CD, your parents don't have to be programmers, for you to put this in your computer and run it. It would be cool if there could be a more mainstream game that could have some sort of programming or algorithmic thinking part. So I just wanted to throw that out there.
Yeah, I would love that. We played around with Jumpstart a little bit, and it seems like a lot of those things are just, you're running around a 3D world, and you can easily avoid any form of education if you don't want to. Even Math Blaster, something I grew up with, doing math, the new one, it's like some shoot 'em up thing. It seems like you can avoid math altogether if you want to, but I don't know.
Hi. My name is Rasha. I'm from Palestine. I wanted to ask you, I taught Scratch back in a kids camp, and I had a hard time dealing with kids. I had no background about it, and they wanted to play Counter-Strike the whole time. And then they were like, let's build Counter-Strike on Scratch. And they did it. It was amusing to see them do that, actually building the stuff. But it was so hard dealing with them. The tips you talked about are great, but I would like to find somewhere where I can get those tips, because I'm gonna forget about them, or get even more tips, or communicate with people who've done that. So what do you recommend? I'm planning to start a Raspberry Pi thingy when I go back and teach kids how to use that. So I need ideas and
Very
tips,
cool.
a lot of them.
Stop by, we'll talk.
Okay, thanks.
So I don't know if there's SVG support in the standard library, but I'm wondering how hard it would be to add that to Turtle, because the current Turtle module can't produce, and that little thing, it doesn't seem like it would be so hard, would be a big way to really make the Turtle module a lot more useful and fun.
Just to be able to show your work off.
Yeah, to be able to produce actually a product with it too.
Yeah.
I was wondering what resources or just knowledge there are about maybe teaching computing or even algorithmic thinking without the computer. An example I was thinking of was, at work we were sending out holiday cards one time, and we had a bunch of people there, and we were sorting these cards, right? Like, and it's something simple, and we ended up implementing, bubble sort and merge sort and all this stuff of all of us just sitting there at a table, like, moving cards around. And I wonder if there's some interesting things that if parents even realize the opportunity when you're teaching kids or teachers that, you can do something physical with real things that if you think about how it's implemented, then that's what a computer's doing. There's no magic behind in the box, even though you can't see it. But I don't know if there's any resources of games or ideas like that to teach kids.
I know the Google, I think if you look up under Google, it's like computational thinking initiative or something like that. They have some things where lessons plans where they try to integrate computational thinking in different subjects. And I think it's just getting started. But yeah, I'd love to see like a larger corpus of that sort of material.
That's awesome. I'll have to look at that.
Just a comment on that, as a Computing Science Unplugged is pretty well, it's a well-done, completed project, and it addresses teaching computer science without computers. Very well done.
Well, thank you for some great new ideas. I have two daughters, 9 and 11, and maybe a little older than you were thinking there, but I don't think so still. Now I have to see if we can do dress design in Scratch or some of these other things. So that's what they're interested in, and actually that's kind of my point or question is dealing with other distractions. Because when they go on the computer, they're not computing. They're not programming. They're playing games and things that are totally unrelated. But I do want to try to capture that. It's difficult.
Yeah, no, the same sort of thing, and the same distraction as, so Minecraft Pi is probably the most popular application on the Raspberry Pi at the moment in my house. And in using Scratch, I think we had a similar problem where it's like, we just want to paint the sprites or give them different costumes and things like that. So, it's different. If you're in a classroom setting where you have to get things through, it's really difficult. In a home setting, I think or a more one-on-one setting, it's easier to kind of set boundaries like, okay, we'll spend this amount of time doing this, then we'll be ready, and then we can go to the next activity. But that's how I've dealt with it, but it's absolutely there,
Okay, we're unfortunately out of time for this session, and they're getting ready to start the lightning talks. You can feel free to come up and talk to Kurt because we don't need this room this second. Of course, there are open spaces, so if you want to set up something like that, please do that. And there's several of us involved with education, so if you have other questions, we would love to talk.